Okay, so this is your flipped lesson for November 17th and 18th in regular physics, since I am out on the field trip this Friday. So today we just need to get some notes down on directions of a vector and how to specify a direction and then how to read a direction if it's given to us. So we're going to go through that. We'll go through a couple examples and then I will show you what worksheets you're going to be working on after you get these notes down. And then just remember that you guys have a quiz on next Monday or Tuesday, depending on what block you're in, on the basics of vectors that we've learned so far, on the basics of free fall that we learned like last week, the week before, and on the basics of one-dimensional motion, which we learned right around when we did free fall, same day. The notes for both those things can be found on Moodle under last week's agenda, and these notes will be posted to Moodle as well as the keys for the worksheet so you can check your work. Your only homework after this lesson is just to make sure you're ready for that quiz and to make sure that those worksheets are done. Okay, so here we go. So, directions of a vector. So there are like two, maybe three, you could argue, ways to specify the direction of a vector. So we can use north, east, south, west, or we can use above or below the positive x-axis, above or below the negative x-axis, to the right or left of the positive y-axis, and then to the right or the left of the negative y-axis. The only other one I can think of is either above or below the horizontal, but that's not as specific because then you don't know if it's above or below the positive x, the negative x, or where it is. So these are the safe ones to use, either northeast, southwest, or you can use reference to the axes. Hopefully we all know this northeast, southwest, never eat soggy waffles, if it helps you remember. And so the one thing that gets confusing for most students is that they'll say something like north of east versus east of north, and a lot of students don't know the difference between those two. So the way that I remember it is I always go to the second direction, so in this case east, and then I move toward north, and that's how I know which angle I'm looking at. So this is an example of this angle is north of east, because you would go to north, and then you would go go to east, and then go north of east, and that's where your angle is shown. That's very different than going here and starting at north, so start at the second one, and going east of north. That's a different angle. Here I've drawn the same vector, or as close as I can to the same vector, for west of south and south of west. And so you can see that if I'm directing you to this vector, where I want this vector to be, I can either use this angle and say west of south, because I would start at south and go west, or I can use this angle but say south of west, so I start at west and I go south. It's really important that you don't just give me the angle, because then I don't know if you're talking about this angle or if you're talking about this angle. Same thing in this case. Is it this angle or is it this angle? So make sure that you tell me which angle you're using, west of south, south of west, however you need to specify it. Obviously there's also east of south and all kinds of other ones. So these are just a few examples, but make sure that you're giving me the right order of the directions. The other thing is, if you really hate this, you're going to see some of it, but if you really hate it and you want to reference your angles, you could have used north, or you could have said above the positive x-axis for this. This one you could have said to the right of the positive y-axis. This one you could have said to the left of the negative y-axis, and this one you could have said below the negative x-axis. So it just depends what you want to use. Either one of these two directional things should work. Okay? And then also just make sure you remember to be in degrees in your calculator and not radians. So now we're going to go to some examples. Let me get this camera for you really quick. Okay. So the first example, and these are meant to sort of help you get ready for the worksheets that you're going to be working on. So you want to make sure that you take notes on these examples and make sure you understand how to do them. And you can always go back and rewatch. Okay. So the first one says to add vector 1 and vector 2. And it tells you that vector 1 is 10 kilometers at 12 degrees north of east, and vector 2 is 15 kilometers at 30 degrees south of west. So the first step that I always do is I draw both vectors on separate planes, just because it makes it so it's organized. So 10 kilometers at 12 degrees north of east. So here's east, here's north. I have to go 12 degrees north of east, so that means that this angle is 12, and this magnitude is 10 kilometers. Okay, so that's the first vector. Vector 2 is 15 kilometers south of west. So west is this way. South of west would be this way. So this is 30 degrees, and this is 15 kilometers. Now, if you want to draw them so that it looks like you're adding them, you can, graphically or visually or whatever you want to do, but you really don't need to. All that you need to do is, remember, you need to get the x total and the y total. So this vector has an x component and a y component, and this vector has an x component and a y component. And I just noted sort of in my head that this x component for this vector is negative, and this y component for this vector is negative. So I'm just going to want to remember that. So I would find the x component first. So in this case, it would be 10 cosine 12. And then minus, because remember the x direction on this one is negative. So minus 15 cosine 30. That's all my x's. In the y, I have 10 sine 12 minus 15 sine 30. And then I would go ahead and calculate that. So I got 22.77 for the x, and then in the y, I'm going to do 10 sine 12. Oops, I'm sorry, I did plus. I need to do minus on the x. So it should actually be, let's see, 10 cosine 12 minus 15 cos 30. So I actually get negative 3.2 in the x, and then 10 sine 12 minus 15 sine 30. And I get negative 5.42 in the y. So now that I have both my x and my y, I'm going to go ahead and draw a new picture. I'm going to plot this. So I'm going to go negative 3.2 in the x, and I'm going to go negative 5.42 in the y, so maybe something like this. And then I can just label it 3.2 and 5.42. And so my result vector looks something like that. This is my result. And so I'm going to find the result by doing the Pythagorean theorem. So r is going to be 3.2 squared plus 5.42 squared. And I get 6.3, and it would be kilometers. So the units matched my original units. And then I need the direction, so I'm going to say at, and then I'm going to find this angle. So it doesn't matter if you find this angle or you find this angle, but I always find the one that's inside the triangle because it's easier because I have the numbers around me. So I want this angle. I always use tangent, so I'm going to go tan theta equals opposite, which is 5.42, over adjacent, which is 3.2, and then I'm going to do an inverse tangent to get the angle. So keep the numbers here. That's going to equal theta, so then I put it in my calculator, inverse tangent of 5.42 divided by 3.2, and I get theta equals 59.4 degrees. So then I go back up here and I say at 59.4 degrees, and this is, let's see, if I start here and I go this way, that means that I'm either below the negative x-axis, or I could say I'm south of west. And then I would just box my whole answer. And that's it. Okay, so let's move on to the second example. Kind of zoom out here. So the second example is more of a word problem. Just want to make sure that you guys can read these okay and kind of dissect them. So it says a man walks 20 meters west. So I'm just going to start by drawing a vector 20 meters west. Okay. And then he gets pushed 10 meters in a direction 30 degrees north of west. So I'm going to go from where he stopped walking 10 meters in a direction 30 degrees north of west. So 30 degrees north of west would actually look like, see, so here's north, here's west. Oops, sorry, that's east. There's north, there's west. So 30 degrees north of west would actually be something like this over there. So off of this end, I'm going to go ahead and draw my 30 degrees and he said he went 10 meters in that direction. So his actual displacement is from this starting point, to this end point. So our result vector looks something like that. Okay. So what I'm going to do, same process as before. They say, what is the man's total displacement? So I'm going to add up all the x's. So I have negative 20. Then I have negative, and if I break this vector into its components, I have this side is 10 cosine 30, so I have negative 10 cos 30. In the y, I have 0 and then plus 10 sine 30. If I do the math, I get negative 20 minus 10 times cos 30. So I get negative 28.7. And in the y, I just have 10 sine 30. So I get 5. So now if I want to redraw my result vector, I want to go negative 28 in the x, so pretty far, and then not very far in the y. But my result should look something like that. I know this is 28.7. I know this is 5. If I do the Pythagorean theorem, I get .13. Let's see, we're in meters. So my displacement is 29.13 meters at, and then remember I need some direction, so I'm going to go ahead and find this theta. And I have all three sides, so I could use sine, cosine, or tangent, but like I said, I really like tangent. So I'm going to go tan inverse of opposite, so 5 over adjacent. And that should give me my angle. And so if I put that in my calculator, I get inverse tan of 5 divided by 28.7, which is 9.9 degrees. So I know this is at 9.9 degrees, and then this is north of west. Which should make sense from the problem, right? Because he was walking west and then he got pushed in a direction north of west. So he's not going to go 30 degrees north of west because he had already walked, right, 20 meters just west. So he's going to be a little bit more west than he would be than the 30 degrees, and that's shown, but he should still be in a direction of north of west. And so that's it. So you're going to go ahead now and work on a couple of worksheets. First one looks like this. Whoops. First one looks something like this at the top. This is the key, but so it won't say key on it. This is what it looks like. This is the problem that they're solving, and this is a really nice worksheet because it does walk you through. Let me zoom out a little bit. It does walk you through all the steps of how to add these two vectors together. So if you want, you can read through that and get a little bit of extra help. But this is all just done for you. You're not working until you get to the back, and then you can go through this worksheet. The key is online. The second worksheet looks like this. It says vector practice problems. You're going to go all the way through both the front and the back. You can stop after number 10 if you would like. If you want to go all the way to number 12, that's fine. But the key stops at number 10, and after that point, you've done enough problems. I feel like you have enough practice, so you can go ahead and stop after number 10. Those two worksheets need to be done before I see you in class on Monday. And then remember, you have a quiz on Monday on vectors, free fall, and one-dimensional motion. Okay? You can rewatch this video at any time.